Asking, is the function continuous at theta is equal to pi? And usually what we do is we just set the denominator equal to 0, but when you set the denominator equal to 0, you have tangent theta, and then you have to solve tangent theta. So yes, it is true it's continuous if tangent theta is equal to 0, but how do you solve tangent theta is equal to 0? You got to convert it into sine of theta over cosine of theta is equal to 0. So what I would do, instead of setting like tangent theta equal to 0 and everything, what I would first do before I start talking about is this thing continuous, is I would take the function they have given us, this h of theta is equal to sine theta minus cosine theta over tangent theta, and I would simplify first to see how this tangent theta is going to interact with sine and cosine. So tangent theta, remember, is sine theta over cosine theta. So really what I have here is sine theta minus cosine theta over sine theta cosine theta. So this is our switch flip idea that we have a complex fraction. Now keep in mind that this is our one fraction and that our numerator is over 1. So when we flip this thing, it's going to look like sine theta minus cosine theta, all of that times the flip of this denominator, which is cosine theta over sine theta. So really at the end of the day, what we have in the denominator is sine theta. So what we will do here is we will say that this function h of theta is continuous if the denominator, which we're left with sine theta, is not equal to 0. Now, some of you might be sitting there saying, well, this sine theta is going to cancel out with that sine theta, and that is certainly true, but it's never going to, this sine theta is never going to cancel out with this cosine theta. So even if I were to simplify this, the sine theta is always going to be there forever. So it's going to be continuous provided sine theta is not equal to 0. So looking at your unit circle, theta is equal to 0 gives us a sine of 0. Over here at pi, we get a sine of 0. So what we see is that sine theta is equal to 0 if theta is equal to n pi, where n is equal to any integer. So the function is continuous if theta is not equal to n pi, where n is any integer. Now, of course, in this case, our theta is equal to pi would mean that it is not going to be continuous at theta is equal to pi. Now, the question also asks what type of discontinuity you have, and in this case, we cannot remove this sine theta because as we discussed, like, yes, this will cross out over here, but you'll still have it in the second term. So because you can't remove it, it does not cross out in the denominator, you can't remove, and so that means it's non-removable. And remember, a non-removable discontinuity is the same thing as an infinite discontinuity. So we have an infinite discontinuity at theta is equal to pi.